find the derivative of x with respect to y, and we are given both variables x and y, right? And we need to first get their derivatives before we divide them with each other. Now the thing is that in the case of x, to find the derivative there is one important formula that will be used, and that is that sine 2 theta equals 2 tan theta upon 1 plus tan square theta, right? From which we can say that if we swapped the numerator and denominator here, we get 1 plus tan square theta upon 2 tan theta equals 1 upon sine 2 theta, which is cosec 2 theta. So simply what we want is we want to cancel out the inverse trigonometric ratio in x and y and get a proper value which does not have any trigonometric ratio in it at all. And in order to do that, what we must do is we must cancel out this inverse trigonometric ratio with the positive trigonometric ratio of the same kind, which means we need to cancel out this cosec inverse with cosec somewhere in this bracket. Same for this, we need to cancel out this tan inverse with a tan positive, just a normal tan in that bracket. So using this formula, what we simply did is we got cosec 2 theta. Now all we need to do is say that t equals tan. So we will say let t equals tan theta in x, and what this will immediately do is it will convert our equation, which was this equation here, by the 1 plus t square upon 2t, the stuff within the brackets, into cosec 2 theta. So once this is done, this cosec inverse and cosec can be cut, and we will be left with an actual value, right? But now what we need to do is we need to resubstitute the value, right? Because what is theta in this case? So obviously for that we will use this equation. So we send the tan over on the left hand side and we get the value for theta, and then we resubstitute the value of theta into this equation, into this value that we have gotten over here. So we resubstituted the value and we get the answer, the final answer for x. Now same for y. So in y's case, the formula being used is a bit different. It's this one, right? We know this formula, the tan 3 theta formula, right? And if you have a look at what is, it's the same thing, right? See, 3t minus t cube, 3 tan theta minus tan cube theta, it's the same thing. So all we need to do is, once again, we need to let t equals tan theta, right, which will allow us to cut tan theta and tan, leaving us 3 theta. Then once again resubstitute the value for 3 theta, which is this tan inverse t, and then all we need to do is we need to divide our d by dy, which is 3 tan inverse theta, with our d by dx, which is our 2 tan inverse theta, and then here you can straight away cut the tan inverse theta and you got the final value. Now in this one we need to find the derivative of x raised to sin x plus cos x raised to x. So let's first separate the terms. We've got a u, which is x raised to sin x. Now as I had mentioned earlier, if you have a trigonometric ratio in your power, then you must use the log rule. So here we use the log rule, right? Now once we've used the log rule, our equation looks like this. So we can use the u into v, the product rule. We can apply the product rule, which will allow us to simplify the equation, right? And we also have to get the derivative for log u. So our equation now looks like this. Now all we need to do is further the simplification, right? Solve it step by step, and in the end we will be left with this, right? And you just cross multiply the u into the right hand side and you get this. Now you resubstitute the initial value of u. What was the initial value of u? It was this, x raised to sin x. So once you've done that, you get the final answer for term u. Now you have to do the same for term v, right, which is our second term. So again we have to do the same thing. First we have to get that raised to x which is in the power, we need to get it down, right? And for that what we will do is again apply the log rule. So we apply the log rule, right? Then we apply the product rule, and in this case you will first have to apply the you will have to apply the chain rule as well, right? Because he will ask you for derivative of log of cos x, which is the same as the derivative of log of x. So it will be 1 upon cos x into derivative of cos x, which is minus sin x. So look, 1 upon cos x into minus sin x. So after applying the chain rule and the product rule, you have got this value. Now again you cross multiply the v into the right hand side and resubstitute the value, and then you just write your whole equation, the first part for the solution for the first term which we got, which is here, here, right, and this term you resubstitute the values and you get your final answer. Again, this time though we have to find the double derivative. That means we need to find the derivative of our x and y in respect to each other, x with respect to y, and then we have to find the derivative of that derivative, right? So first thing that we need to do is find the derivative. So we'll say, okay, what is dx by dt, right? First let's do x, okay, and then on the other side we're also doing y, right? So in this case, since we are doing it with respect to dt, t will become 1, right? So we've already got the derivatives of x and y, right? Now d square y upon dx square is this, right? dt by dx into dy by dt. Here you can see it's the same thing. dt can be cut, right? So what we are saying is we need to divide our dy by dx, which is a upon a sin t divided by a 1 minus cos t, and we get this. Now we need to further do more. We need to do one more round of derivation over this solution. So for that we will use these formulas, right? Because to further simplify it in this way is not exactly feasible. So what we know is that sine 2 theta equals 2 sine theta into cos theta, right? And we also know that in the 1 minus cos t can be written as 2 sine square theta equals 1 minus cos 2 theta. But here you can see 2 theta is being used, and here we only have t. So we can rewrite this t as t upon 2. So 2 t upon 2 is t. So it's the same thing being written in a different way, allowing us to execute these formulas. So sine 2 theta, sine t will become sine t upon 2 sine t 2 sine t upon 2 will become this, and 1 minus cos t will become 2 sine square t upon 2. Now you can cut the sine and the 2's, and you'll be left with cos upon sine t upon 2, which is cot t upon 2. So you got, but you haven't solved the double derivative yet. What you did was you solved one level of derivative and then you simplified it, right? You simplified it, and now you will have to apply this rule. So simply what it says is derivative of dy by dx into dt by dx will be equal to d square y upon dx square, right? It has to be dx square, so you need to multiply dy by dx with dt by dx, and you have to do one more derivative of dy by dx, right? So in our case we will say, okay, what is dy by dx? Let's see, what is our dy by dx? It is cot t upon 2, right? So it says, okay, what is the derivative of cot t upon 2? Okay, it's minus cosec square t. So here we have it, right? Into what is the derivative of dt by dx, and because it's being done by t by 2, so you also will take derivative of t by 2, which is 1 upon 2. Then it will say, okay, what is dt by dx? So okay, all the way back, what was our derivative of x? A 1 minus cos t, but we are talking about dt by dx, so it's the inverse of this, so it has to be 1 upon a into 1 minus cos t. So we convert it to that, and using this we can simplify it further, and you will get this minus cosec raised to 4 t upon 2 upon 4a.